Hi everyone. So this is not a lecture, obviously. This is not a lecture. This is just, me recording and stuff like that. So it's just random recording. We'll just call it random recording. Sure. If you want to consider it random recording, sure. Go ahead. You can consider it as random recording. So by the way, that's an Mbappe kid. That's an Mbappe kid, right? I'm a big fan of Mbappe. But anyways, today's lecture is pretty important. I know that there are people who get scared of physics and maths, and I did some recordings. Now I don't know on Instagram, but I do get few messages like, okay, I know that whenever I say few messages, people presume 100 messages, 1,000 messages. No, not 100 or 1,000. I get like 3 or 4 messages. Sure, some of them are like, um, none of them are like education related, like you know. Um, oh, how do you teach, and how do how do you go, like how do you teach, how do you understand so well, and whatever. I think I'll also do a clip on like how to understand better. But few things that caught my eye was, how do you start, like, because I know that I barked about, oh, you have to do physics, you have to do this, you have to do that. How does someone, like, if now I've been in university for like almost 4 years now, so it's going to be my fourth year. I'll be doing my honors. So a little bit about me, first of all. Obviously you know my name, Tarkar Saad Ahmed, and right about, and I'm going to pursue my honors. That's my plan. I because I'm done with physics. I don't know what's the point of doing honors. I'm typically done with physics. uh Probably I may go for honors in maths, but not for physics, because physics I'm pretty much done, and I don't want to go for honors, like, because it's another like time waste and whatever, right? It's like, ugh, like you can do it by yourself, but you know what? I'll apply for it. Like, it's not that, oh, I just want to apply for it, but I know, like, if you do honors, like, it's easier to do research on, if you do like graduate school and whatever. So I'm not, the only reason I'm delaying is because I'm writing the timestamp so that you guys can click on it. But the only reason honors is good is because it gives you a good grip, like, because the entire year you're going to do honors. So on one semester you're going to focus on doing the experiments, you're going to focus on doing the practical aspects and whatever. And on the second semester, which is typically the second half of the semester, you're going to focus on writing the thesis, writing the paper, writing the research paper, and your research paper should also be good. I myself have published 2 papers, two of the most notable papers. I mean, not notable. There's going to be a Nature, obviously, but good enough to have the most amount of reads. And because I have 1,000 reads, so I had 1,071 reads on my infamous paper, the quantum fluid dynamics. So I also got noticed by the invigilators. I have an email for it, but that's not the point. The point is, how would someone start? Like, all those ranting, all those boasting and stuff like that. How would someone start? Like, how do you even start physics? If you were not a university student, if you are not a high school student, if you are just starting, if you don't know anything about education, and you know for a fact that, so how to start. So if you know for a fact that I need to improve, you need to improve, you need to understand what's going on and stuff. How do you begin? So step one, get your maths fixed. Start maths. Do not start with physics. I know people say physics. I know most universities, what they do is like they force people to do physics. You can do physics. I mean, typically you'd have to do first year physics, but if you do first year physics, make sure you're also doing first year maths. Because if you do first year physics without doing first year, I have made this mistake when I was new to university. So my mistake when I was new to university was that I wanted to uh, eradicate maths because it was like time waste, not time wasting, but I wasn't able to pay that much fees. When I saw the fees, it was like fucking $8,000, like for a semester, like $8,000 per semester is a lot. And I mean, obviously now, like, my scholarship pays off, but when I first saw that, I was like, okay, shit, what do I do? And so I told them that, is it possible to, because in high school there was no there, you have your own choice. That what I did my GCSEs, like IGCSEs and AS level and A level, and you can pick your own course. So you can go physics, chemistry, biology, or physics, chemistry, biology, computer science, or physics, chemistry, maths. And I didn't have maths. I had physics, definitely. Definitely I had physics, definitely I had chemistry, but I didn't have biology. I had CS, computer science, but I didn't have maths. And I did not know that you do need maths. So core thing is that you need maths. And so if you want to start off, if you want to do physics, make sure that you have one easy elective. So if you're on your first year, so how do you start with university? Make sure that you have one easy elective. Let it be it history, be it English, be it French, be it gender studies, something that doesn't have finals in it, because there are courses that are judged. There are courses that are judged based on how much you can, write, how much essays you can write, how much words you can write, whether you were able to complete the assignments, whether you were able to complete um, the the task that was given to you. And if you are able to do that, you get a certain grade. And there is no finals for it, because you must understand, on your first year, universities will always recommend you to do physics and maths, always. If maybe not physics, but definitely maths. 100% they will say you have to do maths. So start off with maths and physics, or maths, notably maths. Start off with maths. Maths, which one? Which maths? Now, if I have done high school, if you have done high school maths, then typically you have finished the calculus 1, which is the limits and derivatives and differentiation, and calculus 2, which is mostly focusing on the integration point of view. You have finished those. But if you didn't, that's completely fine. I know some people, they skip like the secondary school and then directly go to university. You can do that, but which means that you'd have to do the calculus 1 and calculus 2, which means you have to do calculus 1 and calculus 2. Don't do calculus 2 and calculus 1 at the same time, because you will not understand, and you're going to tank your GPA. I did that, and best believe I was in I was humbled. I was humbled. So do not do calculus 1 and calculus 2 at the same time. Do calculus 1 first. Know what's going on in calculus 1. Understand the derivatives, understand the limits, understand, oh, this is how you solve the limit. This is how you solve the derivative. Because the only way you're going to understand integration is if you understand differentiation. Because it's like saying the only way you're going to know how to add is because it's the only way you're going to know how to add, how many items are there. So I'm good. You know what? I'm just going to write the timestamp for this maths. So the how to. So the only way you're actually going to understand how to do calculus 2 is by doing calculus 1. So it's like saying, if I have two bottles here, bottle 1, bottle 2, the only way I'm going to figure out how to add them is by looking at how many bottles do I have. The calculus 1 is more of like, how many bottles do you have, but instead of being in numbers, you're going to have it in graph. It's going to be continuous, and I'm going to teach that. Don't worry about it. And so if you do not know derivatives, if you do not know limits, if you do not know your first year math, like limits, because it's mostly focused on the limits and derivatives, and if you don't understand them or don't know them, you will not be able to solve integration, because the only way integration is being solved is by doing derivatives, by doing differentiation. And if you don't understand them, that's a big problem. I did that, and it will tank your GPA. If you want to do maths, do calculus 1 first. Do not jump into calculus 2, and they will give you a restriction. They will give you a restriction. They should. If universities do not give you, if universities don't, this is 904. If universities don't give you a restriction, then it's a big, big, big problem, and they're forcing you to actually restart the course, because you will restart the course if you do calculus 1 and calculus 2 without any restriction. All right, so calculus 1. Now jumping on to physics. What physics do you start first? You start with first year physics, whatever your first year physics course is. But again, if you are not in university, you start with general mechanics. So that's physics 1050, and the book that you typically use is Young and Freedman. So Young and Freedman, the 15th edition. So you can use that book from the first pages. That'll be the first year physics. So that book alone contains all of first year physics, all of second year physics, all of physics that you want to thoroughly focus on. Thoroughly want to focus on. So for the first, if you're new to physics, or if you're doing first year physics, or if you're doing second year physics, highly recommend that you do Young and Friedman. Young and Friedman, Young and Friedman, Young and Friedman. That book is going to save you tons. You can have alternate books. You can have alternate books. It's completely fine. Nobody's stopping you, but make sure that you have Young and Friedman, because that book is typically used by most universities. I don't know about the states, the US, but in Canada, they use that book almost all the time. For first year engineering, for first year physics, they're always going to use that book, regardless, because that book has everything. That book has equations, that book has notes, that book has 200, 250, 300 questions that you can try and solve. And Young and Friedman. Young and Friedman, there will be sections. So in first year physics, you're gonna have two things. So in first year physics, you're gonna have two things. First year physics, you're gonna have mechanics, the general mechanics, and you're gonna have what you call electricity and magnetism. So on that's physics two, or what you call the first year physics, but the harder level. And you cannot do both of them. Once again, it's a big warning. You cannot do both of them, because think of the general mechanics dangers of first year physics. Physics first year. So if you do, it's like, say, like I said in the maths part, if you do calculus 1 and calculus 2, because physics 1, which is the general mechanics, like I said, the book you can use, Young and Friedman. If you use that book, you're going to see the first chapters that you're going to focus on is going to be written mechanics. It's going to be literally written mechanics, and these are the chapters that you have to do. You have to focus on them first, because they have derivatives in it. They have derivatives in it. And if you want to do physics, make sure that you have maths too. So if you want to do physics, make sure that you have maths with you, because maths, specifically calculus 1, will thoroughly teach you how to do limits and derivatives. Physics is the Physics gives you real life examples where you can implement the calculus 1 knowledge into your the general mechanics one, which is the obviously the mechanics part, right? And the first year, which is the general mechanics one, this is 1250. So general mechanics one will give you real life examples. If you want to do examples of how to solve limits and derivatives, that's your best bet. Your physics 1050. Or not, I mean, I'm using my university course, but the general mechanics, because they will teach you limits and derivatives. The second one, which is the electricity and magnetism, is in the same book, Electricity and Magnetism. They're going to teach you integration, because you're going to go through the circuits, like not circuits, you're going to go through the sphere, and then you're going to divide the sphere, how much electricity is going through, Gaussian law, Ampere's law, Faraday's law, Maxwell law. So, Faraday's law, Maxwell law, and all that stuff. So those have integration in it. And you cannot the mechanics and electricity and magnetism at the same time. It's like saying you're doing derivatives and integration, learning both of them at the same time when you're new, because you will not understand, right? So summarize it for your first time doing physics. The first time, get the first year the for the first time, you have to do general mechanics, and calc 1. First, because both of them, the 14, 12. So long story short, you are going to need the general mechanics 1, which is on the book itself, the Young and Friedman book. You're going to see mechanics written. Specifically, it's going to be written mechanics. Focus on that section only, and only focus on calculus 1. Do not do calculus 2. You will be intrigued on doing calculus 2 and be like, oh my god, this is difficult. But once you do calculus 1, you're going to understand why calculus 2 exists in the first place. And if you want to know directly, the only reason calculus 2 exists is because calculus 2 exists. Right? What else do you want me to say? Oh my god, this, oh my god, that. No. Calculus 2 exists because calculus 2 exists. All right. Next one. After this, when you're, you know, understanding what's going on, when you're under, okay, so I'll say the real reason. The real reason calculus 2 exists is because you're going to implement the calculus 1 knowledge, because you're only going to do differentiation. In real life, there's not only differentiation, there's integration. And you're not always going to add, because in a continuous form, I'm going to explain them, don't worry. If in a graph, and you're typically adding graphs, and obviously you cannot sum up graphs because they will have in real values. And if you have real values, um, obviously you're going to struggle to do summation, and they're going to explain to you thoroughly. All right. Second one. Now you have your calculus 1 done, you have general physics done, you got your explanation and stuff like that. You understood limits and derivatives. You understood how to break down one whole graph into sections, and then you add those sections. Now you're going to add each of those sections. Now you must understand one thing. In a graph, nothing is discrete, right? In a graph, so this is 1611. In a graph, nothing is discrete, it is continuous. You have seen a graph, not a bar graph, a line graph, or a that continuous graph. You have seen that. You cannot add them. When you try it, you're going to, on the first year physics, which is your general mechanics and calculus 1, you're going to understand how to break down those graphs into sections. So you have entire graph, you're going to break them into section. And each of those sections, obviously, you're not going to count them, because if you count the number of the sections, you're not going to add them, because each of those values are different. So you see, if you have graphs like that, the graph over there and the graph over here will be very different. So if you add them, it's you can't do normal summation like you did in kindergarten and high school, right? So you have to do integration and stuff. I'm sorry, differentiation. I mean, differentiation, you have done this in high school. All right. Now you have to know how to add them, but obviously you can't add them. So you integrate. That is where calculus comes in hand. So calculus 2. You got a calculus 1 knowledge, right? Got a calculus 1 knowledge, you got your, I'm just going to come in 2 seconds. All right. So we begin with calculus 2 now, which is the addition point of view, and you're going to add all those graphs, right? So you're going to add this, add every infinitesimal section. Now on a graph, if I were to go to paint, okay, let me just open paint. I hope you guys can see it. Let me just give me 2 seconds. I'm just going to do that. Can you guys see it? Yeah. I know why. Do that now. This is what you're going to do. So let's say this is the graph. So typically you're going to break them down. You're going to break them down into infinitesimal sections, and then you're going to add them. Now, obviously, you can't sum up each of those ranges through summation. You can't do that. And if you use normal summation, obviously you're not going to get a proper value, because it doesn't work. First of all, you can't do it. It's a range, right? And so how are you going to add those values? How are you going to add those graphs? How are you going to add those graphs? You have calculus, obviously, right? If you have calculus, if you now, not calculus, calculus 2 specifically, and you have calculus 2, this is where you're going to start calculus 2. What is the best example? Which example, like which, because in calculus 2, maths alone, in the maths books alone, there are examples. Great. There are examples, but they will not be great examples as compared to physics. Physics specifically, the electricity and magnetism. Because in electricity and magnetism, you are going to encounter derivatives too, because they are going to presume you know derivatives, right? Because if you do because they are going to presume that you know derivatives. So E and M. On the books itself, they're not going to explain much on how to derivate. They're going to give you examples, sure, but they're going to solve it already. So they're going to presume that you know it. So you must make sure that whenever you do study physics, so it's a key idea too. Whenever you do study physics, make sure that they are presuming that you know. And the only way you can actually grab that, oh, I know this already, and make it true to yourself that, I know this. They said I know it, is by learning the prerequisites. You get your prerequisites, cool. Now, calculus 2, you need it. And the best examples, like the best question that you can correlate this with, is electricity and magnetism, which is the first year physics. It is still first year physics. Definitely, it is first year physics, but that only focuses on the integration point of view, mostly on the integration point of view. So you're going to encounter Gaussian law, you're going to encounter Ampere's law. The only reason these laws exist, not because, I mean, yes, you need the for the first year physics, yes, the laws exist. Yes, you have to apply them, but because you're mostly going to focus on integration. The only reason E&M exists in first year physics is because they want you to forcefully understand how to do integration, which is calculus 2. Long story short, if you have done calculus 1, if you have done calculus 1, and if you have done gen mechanics 1, which is the mechanics, you can safely, if you understand it thoroughly, only then you can safely go to calculus 2 and ENM. So that's your entirety for first year physics. Entirety for first year physics finished. Out. Right? Second year. So that's the entirety for first year physics. It took me 21 minutes and 49 seconds. Second year physics. What do you do in second year physics? That is where you're going to do courses that are a little bit higher level. That is where a mixture of differentiation and integration comes in hand. Unlike the first year physics and math, where you are going to encounter differentiation, or you are going to encounter integration. In second year physics, you're not going to focus only on differentiation. You're not going to focus on integration. You're going to focus on both. So in the second year physics, so second year physics and maths, that is if you're not in the university, if you can't go to university, if you cannot afford university, completely fine. But for the second year physics, it'll always be differentiation and integration mixed. And on the last few pages, on the last few steps, you are going to encounter what you call multivariable functions or multivariable derivatives. This is where things will get a little bit difficult. So this is where things will be a little difficult. Why difficult? Because not only you're going to do calculus 3, which is core, core. And the only way you're going to understand calculus 3 is by doing calculus 1 and calculus 2. Because in calculus 3, not only you're going to have differentiation and integration, which again, they will presume they know it. What is calculus 3 going to presume in the book? I mean, you're going to use the same book. I'm going to explain what book you're going to use. I'm going to mention what book what book you are going to use, but they will always say, the book will always say, you know it. Even when the professors will teach you, even when I will teach you. So even when I will teach you, even when I will teach you, even when professors will teach you, I'm always going to say, you know it. Why is it that I'm saying that? Because I have calculus 1 given to you. I have calculus 2 given to you. So pretty much you have to know them. And calculus 3, the only way you're going to know calculus 3 is by focusing on calculus 1 and 2. Right? Now you know calculus 3. We're going to not only jump onto differentiation and integration because obviously you know them, but we are also going to focus on multivariable functions. Why is it that we need multivariable functions? There is one more course that you need in second year. Second year is where things get difficult. You need what you call ODEs, ordinary differential equations. Why is it that you need ordinary differential equations? Why ordinary differential equations? If you're focusing on astrophysics, I've never done astrophysics or I've never done particle physics, but you are going to, or if you're doing thermodynamics, thermodynamics is number one here. thermodynamics is the number one reason why ODE is needed, meaning why calculus 3 is needed. If you don't know what thermodynamics is, if you look at a rocket or if you look at a missile, do you see the thrust? Do you see how much energy they lose? You're going to learn about Booyan's force. You're going to learn about thrust. You're going to learn about engine. You're going to learn about force on aerospace. So these are core for aerospace engineering. So if you're doing engineering, you need to do thermodynamics because let's say, for example, you didn't do well on engineering section. What they will say is go back to physics. I don't know how does it work to on your end or in United States end, but in Canada, what happens is if you do not do well for engineering, so what happens if you don't do well? So if you don't do well for engineering, what they will say, like second year engineering, because engineering also has thermodynamics, or what? Yeah, they do have thermodynamics, thermal engineering. They would do what they call thermal engineering. If you can't do well for second year engineering, what they will say is go back to physics, and they'll specifically tell you to take thermodynamics. The only reason thermodynamics is important is because that is the cornerstone. That's the second cornerstone for second year physics. So if you want to do physics and maths, make sure that you do thermodynamics, because not only you're going to learn calculus 1, 2, and 3, which is core, but you're also going to learn ordinary differential equations. You are going to learn ordinary differential equations. And the only reason why do I recommend doing, so why thermodynamics? Why do I recommend doing thermodynamics is because when you do thermodynamics, you encounter everything. You encounter everything. It makes third year physics and maths easier. If you can ignore thermodynamics, that's completely fine. It's all up to you. It's all up to you. Again, I'm not forcing you, but if you're not in university, if you're not in high school and want to improve, make sure that you have thermodynamics, because thermodynamics will not only have calculus 1, 2, and 3, but it's also going to have ordinary differential equations. Ordinary differential equations. So thermodynamics is important because it will have ODEs, Calc 1, Calc 2, Calc 3, which is core for third year physics and fourth year physics. Why? In third year physics, you are going to encounter multivariable functions in 3D space, in three dimensional, in X, Y, and Z. And thermodynamics, the second year thermodynamics specifically explains that. How to do in 3D space. How does it work on X coordinate, Y coordinate, Z coordinate? They will explain. They're also going to do ordinary differential equation. They are going to explain that. So if you want to do second year physics and want to level up immediately, thermodynamics is number one. Thermodynamics. Second, obviously you have to take calculus 3. Definitely you have to take calculus 3 and ODE. Definitely. That is again, if you're not in university, you have to do calculus 3. So calculus 1, 2, and 3 you have it. Definitely have to take them. And ODE you have to take them. So maths part is finished. The first year and second year, maths part is finished. You have to do, so 28, 37, you have to do calc 1, 2, 3, and ODE. You have to. But for physics, you need to do thermodynamics first if you want to master everything and want to level up. Second is what you call modern physics. So modern physics will have a combination of particle physics, will have a combination of astrophysics, will have a combination of quantum physics. So it's not going to focus on ENM because ENM is a complete different field. ENM is a complete different field. They have a complete different book. Do not worry about that. But if you want to focus on modern physics, it will have a little bit of particle physics, little bit of quantum physics, a little bit of particle physics, a little bit of quantum physics. So modern physics. So that's the second thing you're going to do because it has a little bit of particle physics, which is also important, and it also has quantum physics, a little bit of quantum physics, which is also important. Do you need ODEs here? When I was in my second year physics, so do you need ODE? When I was in my second year physics, I didn't take ODE when I was doing modern physics, and I did well. because there's not much on ODEs. Like they don't focus much on ODEs. They mostly focus on calc, specifically calc 3. Um, but again, if you want to do it, you can. You can do calc 3. I mean ODEs, but it's not necessary to do ODEs because modern physics does not focus on ordinary differential equation as much. You can do. Again, you can do. That's completely fine. It's up to you. But if you want to do modern physics, it's not necessary for you to do ODEs because they've mostly focused on calculus 3. Third is ENM. Third is ENM. You need to understand ENM. Do you need ODEs? Some professors will say yes, you do need ODEs, and the only reason they will say that you need ODEs is because on some universities the way they explain ENM, in my case I had to take ODEs because the way our book explained, our professors explained, was if you understood ODE, it makes it easier to understand what the professor was explaining. But in some cases, if you want to do ODEs, that's completely fine. If you don't want to do ODEs, that is also completely fine. But I know majority of the students will do ODEs. Would I recommend it? Yes. If you want to do ENM, if you want to do ODEs, that's the most recommended route. Recommended route. But modern physics, you don't need it. Thermodynamics, you must. You must have it. Thermodynamics, you must have Calc 3, 1, 2, and ODEs. And especially if you want to do engineering. Especially want to do engineering, specifically the aerospace one, you do need ODEs. You need ODEs. So that's second year physics. So long story short, you need thermodynamics. So thermodynamics, and with thermodynamics, you need Calc 1, 2, and 3, and ODEs. So in some cases, you may do Calc 3 and thermodynamics at the same time. You can do that because on the first few pages for thermodynamics is mostly Calc 1 and Calc 2. So by the time you're actually doing ODEs, and when thermodynamics chapters reach that ODE section, you have an idea. So you can do ODE, you can do Calc 3, and you can do thermodynamics at the same time. Because Calc 3 already begins with something difficult. ODE already begins with something difficult. Thermodynamics begins with Calc 1 and Calc 2, right? And some little bit of high school physics. So thermodynamics begins with that. And by the time thermodynamics reaches that ODE section, you already know how to solve them because they're going to use the first year ODEs, the ODEs that you were learning when you begun the chapter. They're going to use Calc 3 when you begun Calc 3, right? So they're going to use those knowledge. So you can do ODE, Calc 3, and thermodynamics. You can. Yes, you can. ENM also you can. And it is recommended that you do ODE and Calc 3. I mean, Calc 3 is definitely. Without calculus, you cannot do any physics whatsoever. So one thing is that without calculus, you cannot do any physics. No physics can be done without calculus. No physics can be done. You're out. So you need calculus. But ODE you can take. For ENM, you can take ODE because ENM mostly focuses on Calc 3, not ODEs. So you can pretty much leave out. If you want to leave out, you can. But if you want to thoroughly understand how ENM, how does this differentiation work, how does this integration work, recommended to do ODEs. Modern physics, if you want to learn modern physics, so if you want to do modern physics, you can take calc. You have to take calc 1, 2, and 3. I wouldn't recommend doing ODE. If you want to, that's fine, but I wouldn't recommend you doing ODE. So ENM, thermodynamics, you need all of it, definitely. So that's pretty much the second year physics. I don't know. I don't know about particle physics per se, and I don't know about atomic particle physics and astrophysics per se. I don't know them because I haven't done them. It wasn't necessary for me, and like for my major, it was kind of like an elective. Like if you want to, you can. If you don't want to, it's fine. But um, I didn't have to do it because in most cases my core was modern physics and electricity and magnetism. So that's second year physics. Third year physics is upon you. Third year physics, third year physics is more of like, what do you want to focus on? Now, do not ask me about astrophysics. Do not ask me about particle physics. Because I haven't done both of them. I have not done both of them. But for quantum physics, I've done. Obviously, I've done quantum physics. If you want to do quantum mechanics, you have to do quantum physics 1 and quantum physics 2. Because quantum physics 1 focuses on the first 4 chapters. So third year physics. For third year physics, they will always focus on the first 4 chapters. If you want to do quantum physics, now I know that if you, some people will do quantum, if you're not in university, again, if you're not in university, you have to do quantum physics 1 first. Master quantum physics 1. And you're going to focus on light propagation, not light propagation, sorry. You're going to focus on multivariable calculus. You're going to focus on Schrodinger equation. You're going to focus on probability, probability density. Then you're going to focus on, okay, this is how you solve the probability density. This is how you're going to solve the angular momentum in respect to radius. So why do you need quantum physics 1? Because you're going to focus on radius, angular momentum, how to solve angular momentum, how to get the azimuthal angle. And these are core for quantum physics 2. Because in quantum physics 2, they will always presume that you know them. And so quantum physics 1, they obviously they know that you don't know what in the world is an azimuthal angle. They don't know that. But what they do know is that you do know your second year physics. So they're gonna explain on azimuthal angle, radius, theta, and they're going to focus on, Schrodinger equation. Schrodinger equation. They're going to focus on momentum, and then Heisenberg uncertainty. So these are all quantum physics 1. Quantum physics 2, so QP2 focuses on light propagation, like actually using light propagation, actually using um, you know stuff like light, or again they're going to use azimuthal angle. Definitely they're going to use azimuthal angle. They're going to focus on 3D, but they're also going to focus on complex stuff, so complex wave functions, and then they're going to actually implement the equated space, the equated time for 3D space. So that's quantum physics 2, QP2. So they're going to focus on light propagation. They're going to focus on angles definitely, but it's going to be more complex. It's a little bit similar to QP1, but QP2 they use it more complex, and it's depressing. It is depressing. And for QP1, QP2, you need calculus 3. Definitely you need calculus 3. You need vector calculus. You need vector calculus here. So for QP1, QP2, ODE, I mean, or not ODEs, QP1, QP2, PDE1 or ODE2, that's ordinary differential equation 2. So you do need vector calculus. Vector calculus is number 1 here, because without vector calculus, you won't understand shit. The vector calculus, that is the first maths for third year that you have to do. And you need calculus 1, 2, and 3. And you also need linear algebra 1. You need linear algebra 1 here. So I didn't mention that, but you also need linear algebra here. The alg. Linear algebra 1 and 2. If you want to do 1, that's fine. But you most presumably people take linear algebra together, linear algebra 1 and linear algebra. Like you have to take linear algebra 1 first, then you can do linear algebra 2. But if you're not in university, you can just take linear algebra. That's fine. So you can do linear algebra, because obviously they're gonna start with linear algebra 1, then they're gonna explain all the way to linear algebra 2. That's fine. That is for QP. If you want to focus on ENM, so obviously you have to do 30 ENM courses, circuits, electricity and magnetism. I don't know much about 30 ENM course. Actually, I did. Well, let me just check for 2 seconds. What was? Let's see. So electromagnetic fields 1. So you have to focus on electromagnetic fields. So you're going to focus on magnetic fields. So 3956. For E&M, you have to do electrical magnetic fields 1. So you're going to focus on magnetic fields, how magnetic fields work, and this is where you're going to use Gaussian law, Ampere law, Maxwell law, Faraday law in more complex, right? So in a more complex format. So E&M. So electromagnetic fields, magnetic fields. You're going to focus on that. If you don't go to university, if you want to focus on electricity and magnetism for third year, if you want to focus on electricity and magnetism third year, focus on electric magnetic fields. Number one. Electromagnetic fields. Electromagnetic fields. You have to focus on that. That is your core if you want to do E&M. If you want to focus on electricity and magnetism, then you focus on electromagnetic fields. If you want to do quantum physics, then you focus on quantum physics 1, quantum physics 2. If you're in honors or if you have very high grades and if you're doing honors in third year, they're gonna tell you to do quantum mechanics. I didn't do that because obviously I was never told. I wasn't that good that I'm going to do quantum mechanics and quantum physics. But if you want to focus on quantum physics, go quantum physics 1 and quantum physics 2. If you want to focus on E&M, then make sure that you do electromagnetic fields 1 and electromagnetic fields 2. I don't know about particle physics and I don't know about astrophysics. Cool. Engineering also I don't know, because on third year on second year alone you directly move to engineering, so you do completely different for what physics does. And even for third year, that's the same case. Whatever you do on engineering stays on engineering, and whatever you do on physics stays on physics. I don't know much about fourth year because the only 2 fourth year courses I have done is statistical mechanics and fluid dynamics. These are the only 2 courses I've done, which means I also did partial differential equations. I had to do partial differential equations. But for fourth year, I don't know much because these are the only 2 courses that I did. I'm pretty much done with physics, but overall, this is what you would do to make sure that you would master physics and maths without going to university. I hope you understood. If you do have any questions, I'm going to make sure that I'm going to put timestamps and make sure I make it as clear as possible. But if you do have any questions, you're free to comment.